Motor Company in Dearborn, Michigan, is the research center. A concentration of engineers and stylists each year create the Ford family of fine cars. They also explore new concepts for automotive designs, probe new ideas, and develop very special kinds of research vehicles to prove out new features and new ideas. You are about to see the results of one such research effort. This is the spirit of the wild Mustang, bred into a fine machine. There is only one, but it has spurred inquiry and comment from across the nation and from many other parts of the world. Actually, the Mustang is a research vehicle, conceived and brought to the stage of development testing by a group devoted exclusively to evaluating the feasibility and desirability of new automotive design concepts. Concepts that might be applied to future production cars. Why a sports car? The sports car is far from being new in concept. True. But over the years, it has influenced the development of passenger cars in all categories. And this type of vehicle is particularly suited to the plans of Roy Lund, manager of the Vehicle Concepts Department. He explains that his group, in collaboration with Ford's advanced stylists, have in mind certain features, potentially useful in a variety of models, which could best be developed and proved out in a sports car type vehicle. He is thinking of aerodynamically clean body shapes with improved seating positions. Lighter weight, but stronger body structures. Midship engines with proper cooling, and better handling qualities and road holding ability. The other group in the center associated with the creation of this research vehicle was the Advanced Styling Studio, and it was here the functional aerodynamic body was designed. The low-drag, clean front end was shaped, and a safety roll bar was incorporated in the styling concept. The efforts of the styling and engineering groups were given executive support by the president in charge of styling, Gene Bourdonnais, and the vice president in charge of engineering, Herb Misch. Together, these division heads endorsed the project. Having selected a sports car configuration, Roy Lund's group set themselves additional objectives. They would design a high-performance two-seater that would conform to Racing Category 9 of the ruling Fédération Internationale de l'Automobile and to Sports Car Club of America regulations. Because it was purely an experimental car, the engineers chose to use a welded tubular steel space frame, strong and lightweight for the Mustang. The test measurements for the frame were made on an accurate scale model that provided data easier and faster than calculating the many stresses. The model is detailed down to the attachment brackets for the front and rear suspension members. The actual frame was fabricated in California by the custom car builders Troutman and Barnes. In addition to being both lightweight and strong, the space frame can be built quickly. The engine and transmission pose no serious problem. Ford's recently developed V4 engine and 4-speed transaxle combination, designed for front-wheel drive in the German Taunus 12M, proved a perfect solution. While unsuited for forward mounting because of the Mustang's small frontal area, the engine moved to midships not only made reduced frontal area possible and therefore allowed better aerodynamic form, but made for excellent weight distribution because it could be placed forward of the rear axle with no change in the drivetrain. With modifications, New cam, distributor, higher compression head, intake manifold, valve springs, and carburetors, this engine had excellent performance possibilities. The design of the clean, small frontal area body that would be a two-seater and have a midship engine, of course, fell to styling. And after many preliminary drawings, the final design evolved. Clean entry, stylized roll bar, functional air scoops at the sides, a body that housed and reflected the car's advanced engineering ideas. Of course, the car needed a stylized embellishment to capture the spirit of the Mustang in its crest, and this was rendered first on paper, then in clay and wood, finally in metal. The special body was first developed in clay, starting with a wooden form called an armature, which helps make a faster, lighter, and less expensive model. Special hot modeling clay is pushed and formed over the armature. Hot because when cool, the clay becomes firm and hard, perfect for precise modeling. A special bridge mounted on rails ensures that each contour of the side being modeled is accurately transferred to the other side. Skillful hands and watchful eyes of the stylists do the rest, ensuring that every long, sweeping curve is true to the evolved design. When the clay was completed, it was covered with a special plastic sheeting called Dynoc, which looks like painted metal, yet can be applied in a fraction of the time it would take to do a similar job in the paint shop. The American racing colors, white and blue, were chosen for the Mustang. When Herb Misch and Jean Bourdonnais saw the completed clay, they were delighted. With the clay approved, a female plaster mold was formed. The clay was first coated with a parting agent, then with a lime slurry, then covered with Excelsior dipped in plaster. When hard, these plaster molds were removed. The fiberglass body form was made by coating the mold with resin after properly treating the plaster surface, then applying glass cloth over the resin coating. Smoothing the cloth to fit the contours. After several layers of cloth and resin had been laminated, the forms were pushed back into place. When all the forms were joined and the fiberglass and resin laminate had cured, the molds were removed and the accurate fiberglass body form was finished. After being cleaned up and painted, the fiberglass body form was subjected to wind tunnel tests. The tests confirmed the car's clean aerodynamic design and proved the effectiveness of the side intake vents, which are located at high pressure zones in the airstream. Following the wind tunnel tests, the fiberglass body form was sent to Troutman and Barnes. Complete plans, specifications, and all component parts accompanied the car. Roy Lunn checked every part with the builders to ensure that everything would function properly. The body was designed as a semi-unitized construction with the frame, which was now completed. The aluminum tank was installed, as were the one-piece special seats that were designed to be an integral part of the body and frame. The remaining body panels were formed under the watchful eyes of these expert West Coast bodybuilders. And their talented hands and hammers coaxed the aluminum into precise and graceful shapes. When finished, each of the aluminum body panels was carefully fitted to the fiberglass body form to ensure accuracy before they were to be joined and welded to the frame. The completed aluminum body was flown to Dearborn, where the Mustang was finally assembled. First of the advanced features to be installed in the car was the adjustable pedal mechanism, providing for varying sizes of drivers. The brake and clutch master cylinders were mounted on the same unit and connected to the body by flexible hoses. A one-piece competition windshield was put in place. The large, easily visible instruments were mounted in a padded dash with a built-in grab handle. To cool the engine, two special radiators were installed. Each was equipped with a thermostatically controlled fan. And each was placed behind a side intake vent. Including the seats as a part of the body structure was an idea likely to see application in many kinds of future production cars. In addition to strengthening the body, it allowed clean, lightweight seat cushions with built-in headrests that easily could be fixed to the body, and safety belts which readily could be made retractable. Special A-frame independent suspensions were designed for all four wheels. Those in front were equipped with 9.5-inch disc brakes adapted from the Ford console manufactured in England. Combined spring and shock absorber units were installed all round. In the rear, standard 9-inch drums, also from the English console, were fitted. And a new and unique steering assembly was designed, which has a rack and pinion steering gear, a flexible shaft, and 3 inches of fore and aft adjustment. The retractable headlights, spare tire, battery, and gas tank are up front. Access to both front and rear compartments was provided. Front hinge doors on either side. Exhausts through the rear, and all necessary lights were provided. And so the car was completed, ready for testing. Ford's top executives reflected their surprise and delight in seeing this research car put through its paces for the first time. There was good reason for their interest and pleasure. Its advanced features made a lot of sense. They proved completely functional, added styling appeal, and could be applied to many of the company's future products. Although advanced features, such as those incorporated in this development, are usually kept as company secrets for competitive reasons, Ford recognized that this particular research vehicle, being in sports car configuration, would have wide public appeal. The decision was made, therefore, to show the car publicly as a candid example of advanced automotive engineering and styling, an example of the exciting kinds of projects in which Ford automotive engineers and stylists are engaged. Sterling Moss greeted the crowd at the premiere showing of the Mustang at Watkins Glen, New York, on a leisurely lap before the start of the United States Grand Prix. Car and Driver magazine was one of the first of the many publications to recognize the engineering and performance potential of the Mustang, and its technical editor, Jan Norby, was invited to test the car. Roy Lunn went along to answer questions.
I would have liked some kind of support for my accelerator foot.
This is the thing we're going to do. We're going to make the...
But the response is beautiful.
The other magazines shared Jan's enthusiasm.
The Mustang is a V4 for fun.
The car is a real eye-catcher, and the far-out features are all functional.
The Mustang is a very serious engineering study.
Its fresh new appearance, its unique styling, generated immediate interest wherever it was seen. Here at the University of Miami, the Mustang pulls up in front of the Student Union and is engulfed by students who are seeing the car for the first time. As everywhere, they are full of questions, want to know all about a car they had only heard about. The features of the car are explained, starting with the twin exhausts that go through the rear body shell, the twin engine ventilating grills that permit hot air to leave the engine compartment, and the twin horizontal rear lights that house left and right turn indicators and stoplights. The Mustang emblem is also the latch that releases the rear deck lid. Derived from the new German Ford Taunus 12M engine, this road version has a single carburetor, high-speed cams, 11:1 compression ratio, 60-degree V4 block of 92 cubic inches, alternator, twin radiators, 4-speed synchromesh transmission and transaxle with independent suspension and drum brakes. The radiator scoops are located at high pressure areas on the body. For normal operation, the cooling is by ram effect. Otherwise, the thermostatically controlled fans come into play. The cockpit has a complete set of color-coded instruments in its padded dash, including tachometer, oil pressure gauge, ammeter, and water temperature indicator. The steering wheel has 3 inches of fore and aft adjustment. The pedals are adjustable and can be moved back and forth 4 inches by means of an easily accessible handle. The gear shift lever is located on the central console and operates 4 fully synchromesh forward gears and 1 reverse. The handbrake of the fly-off type. Horn, choke, and directional signal control are also on the console. The wheels are magnesium to reduce unsprung weight, and the tires, 550/13s. The spare wheel and tire are up front, where their weight will do the most good. As are the floor-mounted battery, the rack and pinion steering gear, 13-gallon fuel tank with flip cap, and horns on either side. The master brake cylinders are a part of the movable pedal unit and move with it. For the cleanest possible front entry, the headlights swing through 180 degrees for night, a legal height above the road. Go flush for daylight driving. Similarly, the license plate can be flipped down for normal driving or folded away for racing. As a sports car, the Mustang demonstrated excellent roadability on the closed-circuit road course at Daytona Beach. Its fully adjustable suspension was responsible for its optimum road handling and road holding characteristics. On other road courses, the car further demonstrated its versatility. And on the high-speed oval, it proved capable of impressive performance for a car with piston displacement of 1.5 liters, approximately 92 cubic inches. Here at the Daytona Speedway, Bill France watches the Mustang go by, clocked at 120 miles per hour at a comfortable 6,100 RPM. Yes, the Mustang turned out to be the kind of car that dreams are made of. But a dream it must remain. For this car was created by engineers and stylists only to prove out the feasibility and desirability of certain new design features. A number of the advanced features represented in the Mustang, along with its performance and handling characteristics, proved out remarkably well. Although there are no plans to bring the car into production, you undoubtedly will see some of its features incorporated in other cars we do bring into the market. That was the purpose of the Mustang project, a pioneering experimental development by Ford engineers and stylists.